IP is a protocol. Using this protocol, we reach destinations. Devices learns the location. A device learns the location of other device using an address, which is used by this protocol IP. Such addresses, we call it as IP address. And now this IP address, designed very long back, even before we have seen a computer. Even before India had the first computer, this IP address was designed. Which means it was designed in the period where no one knows that network is going to be this big. Very, very long back, IP address was designed. Those period, they allotted, they allocated 32 bits.
Sir,
Yes.
sorry to disturb you. So the last time we stopped like a 128.64, that line we stopped
I
it.
remember that. Yes.
Okay, got it. Okay.
I gave
Fine,
you
thank you.
exercise and all. I remember that.
Okay, sorry, sir. Okay, got it. Thank you.
Yeah. I'm just refreshing the previous class and then I'll take you there. Huh? Okay.
Sure.
So 32-bit is not really sufficient for today's large internet. See, this angle I did not teach you in the previous class. I'm trying to explain to you that this address that we spoke in the previous class is not up to the expectation of today's technology's advancement. Long back it was designed, so they thought 32-bit is big enough. On those days, there was no that big picture of internet. Now, if you got only 32-bit and still you have big network and you got only that same 32-bit, then this need to be properly planned and utilized. Otherwise, if we simply use it and waste it, then it won't be sufficient for everyone to get the internet. When it is only 32-bit and you want to supply internet for the whole world, it has to be cleverly, properly planned and used. So initially what they did is, they said, let us classify according to the user groups and then set the range. So they came up with 3 user groups. User called Class A users. These people, they need millions of address. That's the business size. To do that business, they need millions of address, like a big ISP, BT, British Telecom, or if you take Etisalat, Orido, Airtel, BSNL, big ISPs, Telecom Italia, French X, MTN, Orange, big ISPs. They have millions of customers. So that is one category of users, internet users. The other category, they come in class B, classification B, category B people. They are like, small local ISPs or large enterprises. They need some thousands of IP address. At last, the smallest group, class C, who needs some hundreds of IP address. So million or lakhs, that's class A people. Few thousands, class B. Few hundreds, class C. Now for this category, they set a range of address. For example, class A, any address that is having first octet with 1 to 126. If you see an address, the first number, if an IP address has got any number between 1 to 126, if it is between 1 to 126, they're called as class A range people. Class A. 128 to 191, class B. 192 to 223, class C. This classification helps to use the address wisely. See, class C people, if they are given a class A address, then there will be a huge waste of address. They won't be using it idle, and the others cannot also use because it is given to that class C people. So when we classify according to the requirement and provide them, then we can avoid wastage of IP address. So that is the reason why class ABC was derived. And also, there's another class called class D and E. This class D is ranging from 224 to 239, and this is only meant for applications, multicast grouping applications. So this is called multicast range. See, this is not according to the user group. This is not according to the user and the number of IP addresses needed. This is specially meant for multicasting only. These addresses in this range, these 224 to 239 addresses, they are meant to identify a group. For example, goat, sheep. They are all identifying a group of animal. Goat is a group of animal which has got wool. No, the goats don't have wool. Goats are only for milk and meat. And sheep is another group When I say sheep, what comes in mind is a lot of sheep with good amount of wool to make sweaters for winter. Like a common name, children from 7th standard, which means not the entire school, it means only the group of people in 7th grade. That 7th grade is not a individual person, group of person in 7th grade. Likewise, if I say an address 224.009, it means group of device that runs EIGRP routing protocol. All the routers that run EIGRP is identified with one address. So any packet you send to this address will go to all EIGRP router. Advantage is you don't need to send individually to each device. Multicast address helps to identify group. Multicast range is between 224 to 239. Did you understand this multicast thing?
Yes, sir.
Okay. Now, about multicasting, we will not be seeing again in the CCNA course. This is again covered in CCNP and CCIE. So now let us go to what we need to know in this course. Class A, B, C, and D. Sorry, B and C. What about E? There is also, is there any class called E? No. Actually, after 239 means 240 to 255, not at all in use. This is still under research and development. So this is not a valid range. We have only up to here. Now let us go back to the top. Now this class A, we talked in the previous class, there are 4 groups. Each group is called as an octet because they got 8-bit. And we also understood how the 8-bit can be understood and converted into decimal and back to binary. We'll again have a short refreshing exercise to refresh, to recall after some time. But before that, class A, out of this 4 octet, only the first octet alone, those 8 bits are reserved for network. Only the first octet 8 bits are reserved for network. In that 8 bit, you cannot use those 8 bits for, or any of that 8 bit for host identification. For a device to be identified, you got 24 bits. Out of 32, to identify a computer in a network, you have host bits. To identify the network itself, you got 8 bits. See, network is a group. To identify a group, you have 8 bit. In that group, each computer needs unique ID, that is host. So for host, you have 8 plus 8 plus 8, 24 bit. And 8 bit for network. Right? So How do we represent this? We represent it like this: subnet mask. What is that subnet mask? You see, subnet mask means what? Reservation. We write 255.0.0.0. Why? Because you learned in the previous class, if all the 8 bits are on, 255. That you know. We learned it. To tell how many bits are for network in class A, we write mask, subnet mask, 255.0.0.0. This is to tell that not all 32-bit is host, only 24-bit is host. The first 8-bit is not host. That is what the meaning of the subnet mask. It says out of 32-bit, how many bits are masked to be a network. 8 bits only masked. The other 24 are not masked, not covered, not reserved for network. They are allowed free to be used by you to identify host. That's what we call the subnet mask. Subnet mask tells how many bits are network. For example, if I have an address 100.200.49.250, when I see this address with this mask, it shows that this is the network. And these are host ID, the computer's ID. What is the name of the computer? 200.49.250. In which network? 100th network. In 100th network, the computer's name is 200.49.250. So in the subnet mask, wherever you find 0, they are all host bit. That is for the computer to be identified. Computer or printer or any device that is there in the network that needs IP address. But what network it belongs to? 100 network. 100 network. Did you understand this?
Yes, sir.
So we call this as class A because you see the number 100 is in between this range. Don't see this number. If you see 200, then you will not agree as class A. Don't see this 250. No, you should not see those numbers to decide the class. See only the first octet to decide what class it belongs. Now let us move on to class B. Class B is 8 plus 8 bit for network. The other 16 bit is host. This 16 bit is for network and those 16 bits are for host. So can you tell me what will be the subnet mask for this class?
255.255.
Exactly.
0.0.
Exactly. For class B, this is the subnet mask. And if you find any address between 128 to 191, then it is class B. For example, 178.255 254.290. Do we have 290? No. 255 is the last number.
Yeah, sorry. Yeah, you're right.
210.50. Now, in this, which portion is host? 210. No, host.
Host 210.50.
210.50. 210.50 is the host. And as you are saying, 178.254 is
Network.
How do we say that? By seeing the mask.
Mask.
So that is the purpose of subnet mask, to explain us how many bits in the address is given for network. Now, in class A, we have 24 bits. In class B, 16 bits. Then how many computer can get an IP address in class A? 2 to the power of 24 minus 2. Why 2 to the power? Binary. Why 24? Because 24 binary bits are given for host. Why minus 2? Minus 2 is because if you say this is the network, this is not a valid host ID. 0 is not valid. Likewise, 10.255.255.255. This is also not a valid IP. This is for the network. This is for the broadcast. So we don't use this 2. That's why we put minus 2. I'll explain more detail in some time when we get into subnetting. But in short, what I'm trying to say is IP address starts in a network when the bits of the host is on. When all the host bits are 0, we can't use it. That is network. When all the bits are 1, then you will get 255, 255, 255. That also not valid because it is broadcast. So, how many hosts in one class? See, how many networks are there in class A? 1 to 126. In each network, how many hosts? 2 to the power of 24 minus 2. I repeat, I'm not saying the entire class A will give you only this much address. Now, if you take 1, it will give this many IP. Another, if you take 2, this many IP. Up to 126 you have. Yep. In each class A network, you can have these many hosts. Do you follow?
Yes, sir.
Now, for class B, 16-bit, which means 2 to the power of 16 minus 2. So you got 128 to 191 range, plus in the second octet also you have network 128.0, 128.1, 128.2, and then 129.0, 129.2. You have millions of networks. Here you got only 126 network. But here it is 16-bit. Number of network itself here how much? 2 to the power of 16 networks. 2 to the power of 16 is not million. 2 to the power of 16 is 65535 networks. 65,000 networks. 65,000 plus networks. Okay, so this many hosts per network. I said more than 65,000. Each network can have this many hosts. Now, moving on to the class C. In class C, you have 4 octets. And This is also network. And this is the only host octet. So you got only 8 host bits and 24 network bits. So you will get more networks. In each network you have only 254 IP. How? 256 minus 2. 2 to the power of 8 is 256. 256 minus 2 is 254. 8 bit only, no? 2 to the power of 8 minus 2. That many hosts. So what will be the subnet mask?
255, 255, 255.0.
Exactly. So when I have an address, for example, 200.0.0.1, which one is the host? Dot 1. Which one is network? 200.00 is the network. Don't simply say 200 network. It is 200.0.0 because it has been masked. 24 bits are masked. So it is not simply 200 network. It is 200.0.0 network. So there may be another network 200.0.1. Another one 200.0.2. So you got subnet mask to explain us how many bits in the IP address is given for network and how many are left for host. Are you comfortable with this classification?
Yes, sir.
If you want to make a note, you can make a note, then we will go to next level.
Yes.
You might have noticed in class A, when I wrote the range, I wrote 1 to 126. In the bracket, I wrote 127. The reason is the address that is beginning with 127, ranging from 127.00 to 127.255, 255, 255. This entire range of address is not a valid IP address. This will not come in A or B or C because it is not a valid unicast address. It is not possible for you to assign to any computer. Try assigning this address. It will throw error. The moment you type 127, when you put that 7, when you put 6, it won't complain. When you put 9, it won't complain. When you put 8, it won't complain. But when you put 127, immediately any operating system that is designed as per the industry standard will throw a message. What is the message? It will say, hey, you are trying to give an loopback address, which is not valid unicast address. It will say, loopback address you are trying to give, which is not a valid IP address. I cannot accept it. You want to see that? Let me show you. Now, you see, I'll try to give an IP address to this adapter, starting with 127. You see, when I type 126, no complaint. But when I say 120, I'm going to type 7 now. See, immediately it says IP address starting with 127 are not valid because they are reserved for loopback address. Please specify some other valid between 1 to 223. Why it is 223? You see a notebook. Class C is up to 223.
Yes, 255 till.
No, not 255, 223. See class C. Class C range.
Okay, yeah, correct. 224 start with the D class, so yeah, 223, 192, 223.
So
Correct, okay.
it says valid IP address cannot be 127 and it cannot be beyond 233. So it says give any number 1 to 126 and then 128 to 223. I'll accept. Don't give this 127. That's what it says. Why? It gives a reason why. Because what does it say? Because what does it say here? Why it is not valid? Maybe you are in mute. Because
So I couldn't get your question, sir. Could you repeat?
I repeat the question. Why 127 is not a valid one? What is the reason it says here?
It's a loopback reserved IP address, so cannot assign.
Address. For what it is reserved? It is reserved for loopback address. Now, what is loop back? Looping back means what? Connecting back to you. It starts from you, again it will end in you only. It starts from you, again it ends you. For example, you throw a stone, the stone comes and hits you back. What does it mean? Looping back. Loop back. You throw a stone. This won't happen in the real world. You throw a stone in the air, it will go and fall somewhere. But if it will bounce and come back to you, then it is looping back. Now you have a wall in front of you. You throw a tennis ball. It will loop back to you. It will come to you back. You throw a tennis ball on the wall. It will come back to you. It's looping back. In network also, we need this loop back just to test whether I'm able to throw and I'm able to catch. See, I have seen when I was a small boy, I have seen some people used to play towards the wall. That's a practice they are doing. They are practicing throwing and catching. They throw to the wall, and when it bounces back and come, they catch. They practice. Those people who wants to play tennis, who wants to play cricket, they do that practice alone. When they are alone, they throw the ball, loop back. In that way, they, without anyone's help, they are able to practice their throwing skill and catching skill. Similarly, my laptop want to throw and check whether it can send the data in the network, and it want to catch, it want to check whether it can receive the data. Self-diagnostic test. You can test yourself whether your laptop can send data and receive data. Using this address, you can test. How? You see, When I give 127, it didn't allow me, which means my computer is not configured with 127. But when I go to command prompt and ping any address starting with 127, 127, 30, 113, 30, I get a reply. See, I throw the ball and I get reply back. I can send and receive a packet. When I get reply, what does it mean? My laptop is capable of receiving packet, which means it has sent a packet. So it says 4 packets sent and received 4 packet. Now Madhavan has got a question in his mind. What? Where did you send? From where you received? Is that your question in your mind?
Yes, sir.
This address is not even in this computer unconfigured. It is not configured anywhere. And you are simply putting one random number starting with 127. For example, 127, 50, 15, 5. Again you get reply. On which adapter it is configured, who is replying you, where it is sent, that is your question. How many layers OSI has got?
7 layers.
Okay. What is this command prompt? You know, it's an application layer. Now, from where it is sent? From application layer it is sent. To where it is sent? To the physical layer. You see, the operating system provides you that 7 layer. Operating system is built in with this range of loopback address. Operating system is already built in with this range. When you type 127 address and ping, operating system immediately send the packet to the physical layer. And physical layer will reply back to application layer. What it proves? It proves that OSI layer is functioning very well. Your laptop is good to be the part of network. If you don't get this reply, then there is a problem with your physical layer. Maybe the driver is not properly installed. Maybe the NIC card is broken. The network interface card or the Wi-Fi is missing, or the Wi-Fi is not functioning well, or the driver is not properly installed. Something like that is need to be troubleshooted. So it's a self-diagnostic test. Like a person who want to play tennis, he want to practice himself. He takes a tennis bat and the ball, that greenish orange ball. He hits the ball to the wall. Tuck, tuck. He practices against the wall. He puts the ball hits the physical layer, which is the wall. And the physical layer bounces back to application layer. Again he hits. That's how the practitioner will practice tennis. So the loopback address is like the tennis practitioner or the cricket practitioner or someone who wants to practice throw and catch. It sends the packet from the application layer, goes down to the physical layer, and physical layer replies back if everything is fine, back to application layer. So when you get the reply back, you can say that my PC is eligible to be the part of network. Do you understand now loopback address?
Yes, sir.
So this 127 is a reserved range for this purpose. Now, another range is reserved for another purpose, which is 169254. So this range, 169254, if it begins with this two number, here it can be any number between 0 to 255, any. They are not valid. That cannot be used for communication in public network. These addresses, first of all, you should avoid assigning this address. See, this address, if you assign it, will accept it, but don't assign it. Don't assign it. These addresses are reserved for getting assigned dynamically when there is a problem. I repeat. This range of address 169254 is designed to be dynamically generated by your operating system when there is a DHCP problem. You know what is DHCP?
Yes, I have a basic idea. It's assigning IP address.
Dynamic host configuration protocol. It is used to dynamically assign IP address. Now, if there is a problem in assigning IP address, getting an IP address, if there is a problem, operating system will automatically generate one address starting with 169254, maybe 1.1. That is to inform you that there is a problem with the DHCP. When you see an address starting with 169254, it shows that there is a problem with the DHCP. That is why don't use this address, because it is only for signaling. And what is this address called as? This address has got a name. This 169254 has got a name. What is it? APIPA, Automatic Private Internet Protocol Address. APIPA address. It's called APIPA. Do not assign 169. See, if you try assigning, it will accept, but don't do that. When I have red signal to stop, red signal means it is to say, hey, there is some danger, you stop. Then you should not use the red signal in the road for any other purpose. It's not correct. Red is meant to indicate danger. Then why on the roadside in the shops you keep red color? It will confuse people. They intentionally do that. In the highways, if you see, they intentionally put red color light to gain your attention so that you will go to the restaurants. Oh, that's not correct. That's not correct. There are many other colors. Likewise, 169254 is for a purpose. That is to tell that, hey, you asked me to get IP address from DHCP, but there is an issue in it. Fix it. Just to inform us there is an issue, you fix it. It will generate, your operating system will automatically generate. That's why it is called as APIPA, Automatic Private Internet Protocol Address. This address need to be generated dynamically to signal you that DHCP has got some problem. Instead of allowing operating system to dynamically generate, if you assign, then it is not good. Then the purpose is not properly met. Is it clear about APIPA?
Yes, sir, this is clear.
Okay. So we'll